line V1, learning task number 2, where we're going to go and take a look at plugging switches. And plugging switches is kind of a slang term because they're not just used for plugging. We're going to go and use these just basically as centrifugal motion types of switches. Different than the centrifugal switches that we've talked about inside of motors before. You're going to see that at the end of single-phase motors. This is one that's going to be an external motor that is going to be operated off of centrifugal speeds. And it's going to be something that can be referred to either as being a zero-speed switch or just a plugging speed switch. First of all, let's talk about what plugging is. Plugging itself is where we are going to be running a motor in one direction, forward, and then we momentarily reverse it, put it into reverse to kick it backwards. You've probably done this before on a job site. If you're working with a whole hog, like a large auger, and you're drilling through something and all of a sudden the bit catches and takes off towards something you don't want to drill through, you quickly throw it into reverse. And it pretty much instantly stops. Now, it's not good for the motors to go and get plugged to a stop always. It can be really hard on the motor because you got to think that if we get 300% inrush to go from 0 to 3600 RPM, let's say, in this direction, now if we have to go from 3600 RPM all the way back down to 0, and then all the way back up to 3600 in the opposite direction, we're going to go and have a double of our inrush because we need to go and counteract what we have going on, and then we need to inrush in the opposite way. So we will get massive, massive currents that we are going to have as a result of doing any sort of plugging action. As a result, we want to be careful with it, when we actually allow plugging versus when we don't allow plugging. We're going to cover control circuits throughout this whole V1 line that are going to go and be for not just plugging, using the reversing to bring a motor to a rapid stop, but also for anti-plugging, preventing a motor from being reversed without first, making sure that it has time to coast down so we can avoid that large current. Let's talk about the switch in question itself. Over here is a zero-speed switch, commonly known as a plugging switch. And what it is going to be is it's going to be a shaft coupled. So we are going to have to mount this thing external to the motor. It does not come as part of the motor. And we need to go and make sure we somehow have rotation from the motor that is going to go and be transferred to the switch. What it has, it's got a variable slip disc on the inside, and anytime that my motion, that my shaft is rotating in this direction over here, then what it's going to do is it's going to go and move with that little bit of variable slip. It's going to drive something along so that it goes and closes a set of contacts. Over here we see a set of closed contacts. We see that the other set of contacts gets pulled open. If I were to go and reverse the motor in the opposite direction, then what it's going to do is it's going to open this set of contacts right over here, and it's going to go and close that set of contacts that we are going to have over there. If this thing is not doing anything whatsoever, then what it would sit for this one over here, it would sit with both of these contacts open. If I wasn't running forward or running reverse, if it was just stationary, we would just leave that thing sitting open like that. There are going to go and be a couple different switch layouts that we can go and have. Now we can go and have normally open contacts that are going to be off the same. This one over here would be what we would refer to off of a common. So we'd have a common forward and a reverse. They could also be individual dry ones where they're going to be normally open. I'm going to have a switch over here going over to this one. Same with the switch and switch. These ones over here that are going to be tied together. We still see that they're mechanically connected. That's what this little dotted line here represents mechanical connection between those two, but they are separate as to what they are, meaning that I could go and take in, because they're isolated contacts, I could run 12 volts through one of these and 24 volts through another. They're not sharing the same, common as this one over here was. Just like my normally opens, I can go and have normally closed. The normally closed are going to go and open when this thing runs in forward. It's going to open the forward. When this thing runs in forward, it will go and open the forward as well. Once again, we can either go and have a common, or we can go and have individually isolated sections. Let's put them into a control circuit. Control circuit here has a couple of new components for us, a couple of old components as well. First thing that we're going to talk about is this thing over here. This is going to be a forward reversing contactor, and I see that it has an interlock, a mechanical interlock that is going to be on it that is symbolized by that dotted line. The mechanical interlock prevents both of these contactors from operating at the same time. Then we're also going to have an additional layer of interlocks, which are going to be my electrical interlocks. Okay, keep those two straight. Mechanical prevents actual physical movement. Electrical prevents energization of the coil, meaning that if I were to go and energize one of these, I don't care which one was energized, the reverse one here, if I were to go and carry current through to the reverse one, we'll worry about where the current comes from later on. The reverse would go and energize, which would open this, which would prevent us from being able to go and energize the forward one. These are common components that we are going to go and have when we are dealing with forward and reversing contactors. You'll note as well that there is an overload that is going to be placed over here. The overload is going to go and shut the motor down during forward. Now I'm going to go and have my overloads actually connected to the motor winding itself, but I'm not going to have the overloads placed into my reverse path, because during my reverse path, remember, I'm going to be seeing an extra doubling up of my inrush current. So I don't want to go and place my overloads, which are designed for regular operation. I don't want to place them into this reversed one over here. Other component that we're going to talk about is going to happen at the motor itself. So I'm going to go and have my set of contactors. We'll just draw a nice set of contacts. My three-phase lines are going to come in, and then I'm going to go down to my actual motor itself. There'll be overloads in there and stuff as well. But at the actual motor terminals, or at the terminals of the contactor or something like that, we're going to go and have what's referred to as a lockout relay coil. And a lockout relay coil is just going to be a pinning of our switch. What it basically does is it's going to go and have some sort of mechanical arrangement that differs from manufacturer to manufacturer, but basically it's going to have a set of insulated pins over here that are going to go and get deployed. Ka-chunk, they're going to push up like that, and until I energize this to retract them, pull them out of the way, I cannot wiggle that bar back and forth. And this is a really, really important thing to go and have that. If we don't have that in there, this lockout relay coil over here, then we can run into issues where somebody could go and push the motor itself. Let's pretend that this motor is attached to a big giant saw blade over here, that somebody could go and push that motor into the forward direction. When they would do so, it would close this path over here, and then for a brief instant, the reverse would kick on, and we'd get this blade that somebody just pushed forward by their hand, and ka-shing, it's going to just kind of kick back like that, slice off some fingers, WCB, all sorts of headaches. Not to mention fingerless work. We don't want any of that. So we are going to go and have this lockout, because what this lockout prevents is us from being able to actually move the centrifugal switch. We can still move the load, but it prevents us from being able to move the centrifugal switch until this thing has been operated. Once this thing has been powered up, once we've actually run the motor, this is going to go and pull those pins out of the way. And then those pins are just going to get held down by the switch itself, which would at that point be pushed over towards that forward direction. We'll come back to that one in a minute. Let's talk about the actual operation that we have inside of here. My operation for this is going to only apply, because it's plugging, which means rapid braking by reversing. It's only going to apply enough reverse until the motor quits moving. Once the motor quits moving, then it has to go and shut the reverse section itself actually on. So let's start by operating this thing in forward. First of all, if we take a look, we see that up until this point here, there's no path, no complete path for current flow. Therefore, this thing is going to be shut off. As soon as I press the start switch, we're going to have current that's going to travel through here, through the normally closed R. It is going to go and energize my F coil and leave on the line over there. As soon as F energizes, it in turn is going to go and close this normally closed contact. And once it does that, then we can take our finger off the start push button, and we are now going to be sealed in and operating. Standard 3-wire control that we are going to go and have. Well, as soon as we seal this in and operate, that's going to be our forward contactor. The forward contactor is going to go and close all of my motor contacts, which is going to go and energize my motor, as well as it's going to energize the lockout relay coil. So those little pins that we had in there before, as soon as we energize the motor, we energize the lockout coil, those little pins go and retract. They're gone now, they're out of the way. The motor starts rotating, and because the motor starts rotating in forward, it is going to go and move this switch up to here. This switch is now going to go and be carrying current through, but it's only going to get up to here because this is a forward normally closed contact. Right now, forward is energized, which means that this is going to be sitting wide open right now, so we cannot go and complete our path all the way through. As soon as I go and hit stop, so I'm just going to go and hit the stop over here. The stop is going to go and take out this top line over here. Take out the stop. As soon as the stop happens, it is going to interrupt all of my current through to here. And as soon as it interrupts my current through to there, what it's going to do is this de-energizes, which means it is now going to go back to being normally closed, and my reverse coil is now going to go and energize. So the forward coils are going to go and shut off. The reverse coils, they'll have to be two separate coils and contactors. The reverse coils are then going to go and kick in, and we're going to go and reverse that motor. We are only going to reverse that motor for as long as the motor is still coasting forward, because as long as the motor is still coasting forward, that motion keeps this 0 speed switch pinned up against there. But as soon as that motor gets all the way to the point where it's no longer running forward, it's going to go and open that set of contacts. So it's running, we ran it in forward, we kicked into reverse, and now it's just coasting its way down. Well, it's not actually coasting, it's reversing its way down, and it's going to get to the point where my rotation has been go forward, and now it's going to back that off until we're at 0. Once we get to 0 RPM, this switch opens. As soon as this switch opens, nothing happens. As soon as it gets back to open, it's going to slide past these, which are going to have been, at that point, unlocked. It's going to go back to here. As soon as it gets back to here, it's going to go and drop this out. As soon as it drops this out, it de-energizes that, de-energizes the lockout relay coil, pins this right over here, and we no longer have current going through here. We also don't have current going through the top one. So ultimately, what this one is doing is it is just shutting our motor down. It is stopping the motor from running it forward by temporarily running it in reverse until it hits 0 speed. Okay, let's talk about anti-plugging. Anti-plugging is also a thing that we deal with on our 0-speed switches. 0-speed switches are really great for anti-plugging when we are worried about somebody accidentally starting the motor in reverse when it was running in forward. It can be really hard on a lot of our equipment, you know, belts and drives and things like that. If we all of a sudden, bang, just yank that thing from going forward all the way into reverse. So we want to avoid it for their sake. We also just want to avoid it if it's not necessary, just for the amount of inrush that we're going to go and take in. Let's take a look at how that operates inside of here. Once again, same components. We have a mechanically interlocked forward and reverse coils. We're going to have electrical interlocks ahead of them. The forward is going to interlock the reverse is going to go and interlock the forward. And then we are going to have a bunch of our other control after that. Looking at this, I see I've got a normally closed 0-speed switch that's going to be utilized on this one, which means that when the speed switch is at 0 operation, both of these are going to be closed. When the speed switch goes into a, let me just erase these here. When the speed switch is going to be running in forward, it's going to pop the forward one open. It's opposite to what they have inside of here, and it's going to go and keep the reverse one closed. So we'll have these ones here where we're just going to go and interlock from either one of these. Going through our operation, we're going to go and start in forward again. We might as well. At the instant before energization, we would have power all the way up to all of these components. Okay, it's just going to be waiting there for us to go and either hit the reverse or the forward push button, whichever one. If we hit the forward one, that would close this in, which would mean that we would travel through that, which is normally closed. It has not been energized, therefore it stays normally closed, all the way up to my forward coil. My forward coil would energize, which would open this one over here, and simultaneously close this one over here, my seal in contact, and then my current heads out through my overload contacts and out. At that point, this thing would be running in forward. I can take my finger off of the push button. When I take my finger off of the push button, we'll just lose that little section over there, but I'm going to go and continue operation. The important thing to note is that when I start this thing up in forward, the motor is going to move in forward, which means that this over here is now going to go and sit open. So now we've only got current available up to here and up to here. And this is going to stay open as long as that motor is operating in that forward type of direction. I'm going to call it clockwise over here, forward. I can try and press the reverse button all I want. You know, I can press this thing a million times over, but you see that there's no way for us to get current all the way through here. So if the motor's already running it forward, we cannot go and reverse it. The only way to go and make this motor go into reverse is first to go and stop the motor, so interrupt current there, which would go and kill all of this, which would go and kill that forward coil, which would go and kill this contact over here. We would send this contact back to being normally closed, etc. So as soon as we go and hit stop, it knocks out the coils over here. All of these go back to their default positions, their at-rest positions. But what is happening is that right now my motor is still coasting down. As long as my motor is coasting down, this is going to go and stay open. This one is going to go and stay closed. It's off the reverse, so it's being held closed right now. This is going to go and stay energized up to there. But as much as I try to depress this reverse button a million times over, I'm not going to be able to go and start this motor in reverse until this motor itself has actually finished coasting down. Once the motor gets down to 0 speed, then this is going to go and close. And at that point, I would be able to go and press my reverse button and fire in my reverse. Close that in, seal that in, open these up, and then my motor would start running in reverse and it would open that switch over there, which would prevent me from going back into forward. Very useful when, you know, that sudden plugging, accidental plugging would cause an issue. Now, not a ton of motors are actually going to be forward and reversing. It's, you know, it really depends upon the application. Most motors in industry honestly just run in one direction. But sometimes you do have something where you need to go and be able to run it in opposite directions, you know, generally dealing with materials movements or lifting and winching and things like that. These would be the places where we would see this whole concept of the anti-plugging being, you know, useful, because we would want to wait until, you know, your large conveyor belt or whatever has finished coasting down before we go and start in the opposite direction or something. Okay, that is going to be our plugging and anti-plugging. Once again, just to reiterate, these things, when there is 0 speed on the actual, whatever's, you know, driving this thing, the shaft, then I'm going to be sitting with my contacts, all of my contacts at their at-rest state. So right now, if this thing was sitting at 0 speed, everything would look like this. If I were to go to forward, everything would look like this. This switch would look like that. This switch would look like that. This switch would look like that. It would be open, and this switch would look like that. It would be open. Because it is trying to go forward, it's going to go and keep this reverse side pinned. It's going to keep this reverse side over here pinned as well. It's going to keep this one open over here, and it's going to keep this one obviously open over here as well. That would be it inside of forward. And if I were to go into reverse, opposite thing is going to go and happen. If I were to go into reverse, that one would close. This one over here would close. This one would stay open because it's going to be, you know, held open by the fact that we're pulling towards the reverse. This one would open, and this one over here would open as well. And once again, these forwards would go and stay closed off of those. By the way, I don't know if I mentioned it right at the very beginning. This section over here is a separate switch to this one over here. They're not joined together. They're just showing 2 different types of normally open switch. One that has a common, one that's got individual contacts.